Okay, so let's talk about special segments in a circle. So theorem 10.15 tells us that if I have two intersecting chords in a circle, this is how they relate to each other. I can take AE and multiply it by EC, and that would actually equal BE times ED. Pretty straightforward, right? So let's do that with this example below. X times 8 is going to equal what, class? 9 times 12. I can already tell that when I divide by 8, this is not going to come out evenly. So let's just say X divided by, or X equals 108 divided by 8. Put that in a calculator, you get 13.5. Pretty straightforward, right? May I go? Okay, why don't you draw this picture? Okay, so this says, biologists often examine organisms under microscopes. The circle represents the field of view under the microscope with a diameter of 2 millimeters. Write that in there. This is a diameter of 2 millimeters. Determine the length of the organism if it is located 25/100 millimeters from the bottom of the field of the view, round to the nearest hundredth. So what can you say about this? Times what by each other? 0.25 times what? There's not two segments here. There's a full segment and then there's a little segment. 2 minus 0.25 would be 1.75. So we're going to multiply 1.75 times 0.25, and that should equal what? Well, first of all, he told me this is a diameter. What does it mean if this is a diameter? What does that tell me about it? It splits this in half. Therefore, this side must be congruent to this side. And if I don't know what this is, what would I call it? X. That means this one's X too. It's okay to have two unknowns if they're exactly the same thing, right? So I have X times X, because the diameter splits it in half. So I now have 1.75 times 0.25 is actually 0.4375 equals X squared. And now what do, Devin? Take the square root of both sides. If I were to put that into a calculator, I would get X equals about, actually, 6,600. So the organism is about 66 hundredths of a millimeter. Okay, so let's talk about the second theorem. So theorem 10.16 says that if we have a point outside of the circle, so basically we've got two secants intersecting on the outside of the circle. If they're intersecting on the outside of the circle, then, here I'll read the normal definition to you. If two secant segments are drawn to a circle from an exterior point, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant segment and its external secant segment. It's a lot of secant segments, right? So basically what that's telling you is that if you have an external secant segment, which would be AB right here, and you multiply that by the whole secant segment, which would be AC, then that is going to equal AE times AD. So this one's the same as the last one, only you're not multiplying this times this, you're multiplying this times the whole thing and comparing it to this times the whole thing. All right, so let's use that one. So help me out with this diagram down here. 8 times what? No, this is where you have to be careful. No, 8x would be 8 times x. It's 8 plus x equals 10 times what? 10 plus 24. So 8 times 8 is 64 plus 8x equals 10 times 34? Or should we just write 340? I think you guys can do that. Subtract 64 from both sides. Give this what? 8x equals what? 276. If you divide by 8, you get 34.5. Questions on that? I can. So that tells me that this segment right here would be 34.5. Okay, so theorem 10.17. So just like the last one, if we have an exterior intersection, but this time we have a tangent and a secant. Well, I can't multiply WX by anything, right? So we're going to start with this secant. WZ times WY is equal to, can anybody guess? WX times what? Times itself. Okay? So the same as the last one, only there isn't anything else to multiply by, so you just have to square it. So let's use that for this one here. Now look at what we've got down here. This is what makes, can I move down? This is what makes this so hard. Watch yourself as you're doing these. Okay? All right, so let's start with this side. This side's a little more difficult. So I have to multiply this right here, x. I'm going to use a bracket to make sure I don't make a mess of it. X times what? No. The whole thing. So you have to be careful. You have to add x and x plus 2 and multiply that by x. Okay? Is going to equal x plus 4 times x plus 4. And now we're dealing with some pretty heavy algebra, right? You don't think so? You'll see. All right, so let's simplify in here first. So I have x times 2x plus 2 in here equals, now this, you can FOIL, you can use the box method, or if you know your, if you know, I'm glad you're so excited, Connor. If you know your perfect square trinomials, you would also know that this is x squared plus 8x plus 16. Okay? Good. There's an X and an X in there, so there's two X's plus 2. No. No. Hold on. Hold on. Let me get there. Now I've got 2x squared plus 2x equals x squared plus 8x plus 16. I need you guys to stop talking. Now what do? I've got to subtract it and put it all on the other side. I'm taping. So the side talking needs to stop. Alright, 2x squared minus x squared equals x squared. 2x and a negative 8x makes negative 6x, and negative 16 all equals 0. Now you can use the X box first. If the X box didn't work, you could complete the square. If you don't like completing the square, you could use the quadratic formula. That's what I'm saying. That's why I'm not going to get there with you guys, because there are several ways to do these, right? And many of you had different teachers that taught you different ways to do this. The easiest old school method is reverse FOIL. X times x would make x squared. I need two numbers when I multiply make negative 16, and when I add them make negative 6x. 8 and 2. Which one's going to be negative? The 8. One of them has to be positive, because a negative 8 times a positive 2 makes a negative 16. No, it cannot be negative 4, because negative 4 and negative 4 would make negative 8x, not negative 6x. Guys, I can't go over this right now. Okay? I don't have time. So I now need to split these two up and say x minus 8 equals 0, or x plus 2 equals 0. This would be x equals 8. This would be x equals negative 2. Which one works? No, not both. Look at this. This doesn't what? Doesn't what? It doesn't make sense. Can I say that x is negative 2? Would that be a distance of negative 2? No, so it doesn't work. There's your answer right there.
If it's negative, you gotta make
If
it's in a measurement.
If it's in a measurement. If it was only this one was x, it could be negative 2, because negative 2 plus 4 is positive 2. So that would work. Okay, good job, guys.